2022, ADMA paper 2, question 12. The curve y is equal to e to the power 2x minus 5 meets the x-axis at P and the y-axis at Q. Find the coordinates of P and Q. So to find the coordinates of P and Q, you know that on the y-axis, x is always 0, so the coordinates will be 0, some y, and then on the x-axis, you know that y is always 0, so x can be anything. So now to find the y coordinates on the y-axis, you can simply substitute these coordinates in there. So you have y is equal to e to the power 2x minus 5. So when x is equal to 0, you have e to the power 2 multiplied by 0 minus 5. And then this will be e to the power 0 minus 5. So any number to the power 0 is 1 minus 5. So we have minus 4. So the coordinates, is it P? Yeah, the coordinates for for Q are 0, negative 4. And then we also have P. So the coordinates for P will be, you know that y is 0 on the x-axis. So you can say 0 is equal to e to the power 2x minus 5. And then you can take the 5 to the other side. And then introduce the natural log since you are trying to solve for x. So I have ln 5 and ln e to the power 2x. And then using rules of logarithms, we can drop the power 2x so that we have ln e. So we know that ln e is the same as log e of e, and we read this as to what power should you raise e to get e. So the power is 1, so that means ln e is 1. This is something that should always be in your head. This is 1. And then to solve for x, we can divide both sides by 2 or multiply both sides by half. It's all the same. So that we have half ln 5. So you can either leave it like this or treat this as a power of 5 and write it like this. So that means the coordinates of P are, I'll use this version, half ln 5, 0. So that means we are done with part 1. And part 2 is saying sketch the graph of y is equal to e to the power 2x minus 5 for the domain negative 2 to 1. So to do this, we can start by making a simple table. Although we have several other methods which you can use without even using the table by just drawing the basic one. So we can have x and y, and then we already have these 2 points. So when x is 0, y is negative 4. This one here is like 0.5 multiplied by ln 5, which will be 0.8. So this is like 0.8, 0. And then you can find another point. Since the domain is from negative 2 to 1, you can find the highest point when x is equal to 1. So when x is equal to 1, y is equal to e to the power 2. 2 times 1 is just a 2, so we have this. Then we can punch this on our calculator. So you have this minus 5, so you're getting 2.389. You don't need this accurate, so you can just get you can just get it as maybe 2.4 somewhere. If you need a few other points, you can go ahead and add them. So since the domain is from -2, we can try to find the smallest point, which is probably close to -5, probably 4.9 or something. So this will be simplifying this, e to the power negative. So we have 2 multiplied by -2, then minus 5. So this is like -4. So we have e raised to the power -4 minus 5. So this will give us -4.98. So this is close enough to 5, but not really a 5. And then lastly, you can include any other point, but I think these points are enough. So now let's make a sketch. So I'll use a small piece of paper because I'm using my phone and a full paper may not fit on my screen. So now the domain is from -2 to 1. So on the x-axis, you only need these numbers from -2 all the way to +1. And then the range will be the smallest value of y to the largest y value. So in this case, the smallest is -4.95, which is approximately 5. And then the highest will be 2.4. So let's make a sketch with this information. So this is more of the negative y values than the positive. So the highest should be positive 2.4. So maybe we can have our 2 here. Of course, I can use this as my y-axis since we don't have a lot of numbers on the x-axis. So we can say 2.4 will be somewhere here. Then you have a 1, a 0, this will be -1, this will be -2, this will be -3, -4, and finally we have -5. So this will be my y-axis. So y-axis will be here, and then my x-axis will be here. So you only have numbers from -2. So it's more of the negative y values than the positive, like this. So now we can plot our points. Of course, we have a horizontal asymptote on the point y is equal to 5. So this curve can get as close as possible to this line, but it cannot touch it. So the first point is we have -4.9, which is almost -5. So it should be somewhere here. And then our next point is 1,2.4. So 2.4 Actually, let's start with this one, 0, negative 1, 0, negative 4 rather. So that point is here. And then next we have 1, 2.4, 1, 2.4. So 2.1, 2.2, 2.3, 2.4 is somewhere there. And then now you can join these points with a smooth curve. And of course, it is meeting the x-axis at this point. So maybe you can include it as well, like that. And then you can draw a smooth curve passing through each of these points. And of course, you can't use a pen. I'm only using my pen because you won't be able to see anything if I was to use my pencil. So this is what the curve looks like. So this is y is equal to e to the power negative, actually, e to the power 2x minus 5. So this is our graph. And then part B, which is the easiest. So find the equation of the straight line which must be drawn on the graph of y is equal to e to the power 4x to obtain the solution of the equation x is equal to ln the fourth root of 6x minus 5. So to solve this one, you have to mess around with these terms to obtain this somewhere. So the first thing I'll do is to get rid of the natural log. As you can see, we have no natural log there. So to do that, remember that ln the fourth root of this is the same as log e of 6x minus 5. So it's like you have something like this. So now you can convert this from log form to exponential form. So this is like e to the power x is equal to the fourth root of 6x minus 5. So we are getting somewhere. As you can see, we now have e to the power x, but we don't want e to the power x. We want e to the power 4x. So in order for us to do that, we can raise both terms to the power of 4. So that this times this, you have 4x. So this is easier than I thought. Then this and this will go because this is like 1 over 4, and then you are multiplying it by 4. So 4 into 4 is just a 1. So you have this. So when you look at this and this, you can see that the two are the same. So I can substitute my y in this because I know that e to the power 4x is simply a y. So we have y is equal to 6x minus 5. And you are done. This is the equation we are trying to find.